Okay, we're going to look at section 3.5. Okay, this is our rational function section. So first off is going to be rational functions are in the format, okay, P of X over Q of X, okay, and we do have to make sure that we don't let P of X or Q of X equal 0, okay? We're not allowed to divide by 0. So some examples of this, very simple basic, 1 over X. You may have something like 2X plus 7 over X squared minus 9X plus 4, okay? Or we may even have something like 3X squared plus 8X minus 2 over 6X squared minus 9X plus 1, okay? Now, this one, this first one, this 1 over X, okay, specifically is called the reciprocal function. Now, in just a little bit, we'll be talking more about kind of moving this around, okay? But what's going to happen here, guys, is when you do 1 divided by really, really large numbers, you get really, really tiny answers, okay? Now, just the opposite of that is true. If I divide by really, really tiny numbers, I actually get really, really big answers, okay? So when we talk about our reciprocal function, okay, what we have is if we're going to talk about f of x equals 1 over x, okay, graph picture-wise, this is the graph that looks like this, okay? Now, a couple things here that we're going to wind up talking about. They may do these more in depth a little bit later, but I'm going to go ahead and hit it now, okay? Because I feel like we need to, you know, have that discussion about it now. Is first off our domain. Okay, now there's a couple of different ways that they may do this. I am perfectly content with saying x can't be 0. Okay, you can't divide by 0 up here. You may see this done as the union of two intervals. Okay, the range looks very, very similar. Again, I would be fine with y can't be 0, but you may see it done like this. Now, when we talk about increasing and decreasing, guys, this graph is kind of always losing value, okay? So it actually decreases on the entire interval. So negative infinity to 0 with 0 to infinity, okay? Now, with this one, instead of saying it's continuous on the same interval, we can say it's discontinuous when x equals 0, okay, when that comes up. Now then, we do need to talk about these little dashed lines, okay? Now, if you remember, okay, these are sometimes what I have referenced as I'm not touching you lines, okay? The graph gets really, really close. Think about that game where it's like, I'm not touching you, I'm not touching you, I'm not touching you, okay? And you get really, really close, but you never actually touch, okay? So what we've got here is that. So those are called asymptotes, okay? And I'm well aware that I've been told I add an extra A sound in the middle of it, okay? But we do have a vertical asymptote, and these do need to be written as equations of lines. So since it's a vertical one, it's of the form x equals, and it is at 0. We also have a horizontal one on the x-axis, which is at y equals 0, okay? Now, a couple of other things. This function is an odd function, okay? And because that it has origin symmetry, okay? Remember that origin symmetry or symmetry with respect to the origin is the one where I can put a push pin on the origin, I can turn the whole thing 180 degrees, and I will land right back on itself, okay? So we're going to take a look at graphing, okay? A couple of these lovely little buggers. Okay. So if we were to do something like, okay, now, helpful hint here, this is down here with the x. Stick that lovely little darling in a set of parentheses, okay? And that means, again, anything in the parentheses with the X does our left and right stuff. It does the opposite of what we think. So this is going to go left 1. Now, when we talk about our grid space, okay, we think about that set of axes was our asymptotes, okay? So now, if we're going to talk about where those asymptotes go, let's start with the horizontal one, okay? If it goes left 1, it lands right back on top of where it was, okay? Now, vertically, this one's also got to go left 1, so it's going to land up over here. And then if you remember, the graph was in kind of this corner of those I'm not touching you and this one. It stays there. So you're going to kind of hug and hold both sides, okay? So and that gives you a basic graph, okay? Guys, you could certainly plug in values. If I was trying to find values, I could plug in 0, I could plug in 1, I could plug in 2, I could plug in -2, -3, things like that, and get values if I was trying to get a little more specific. But if all we're trying to do is a rough go of it, then this is what we've got. Now, if we want to talk about domain, and again, I'm going to do this in kind of that shorthanded notation, X cannot be -1. Guys, I would take X plus 1 and say it cannot equal 0. Solving for that, I get X can't be -1, okay? That also is where that asymptote's at. Range, okay, is I've got that asymptote sitting on 0. So that means Y cannot be 0. Okay, and again, I'm kind of doing the shorthanded notation here. Increasing, if they ask you about an increasing interval, it's never doing that. If we talk about a decreasing interval, okay, it's the entire time. Now, with this, when we talk about decrease and increase, we do not get the option to do the not equals version, okay? Those actually have to be done on the intervals, okay? So now let's take a look at another one. Okay, so taking a look at this one, okay, again, that little set of parentheses there just kind of help us remember what's going on. This is going to, again, do the opposite inside that parentheses, so this is going to go right 2, and then the -1 is going to be down 1. So here's my grid space. So here we go. Starting with that horizontal asymptote, we're going to go right 2, down 1. Okay, so that actually does show me that it moves. So it's going to go to there. And then talking about our vertical one, we're going to go right 2 and down 1. Okay, so the only part of that we really see that's modifying is the right 2. So now we see here's kind of that intersection. And again, I need to make sure that I stay kind of off of my vertical and my horizontal asymptotes. Okay, so we've got that. Domain-wise, again, you could set that X minus 2 cannot equal to 0. So X can't be 2. Range here, we've got that horizontal asymptote sitting at -1, so Y can't be -1. Increasing, again, we have none. Decreasing, okay, is going to be from -infinity to 2, and then 2 to infinity. Keep in mind, when you're doing your increasing and decreasing, it is always based on your X intervals, okay? The decreasing and increasing is what the Y values are going to do, okay? Now, kind of a partner to our 1 over X function is 1 over X squared, okay? Now, what this is going to do with our grid space, okay, is this is going to be up here, and this is going to be over here on this side. Now, we still have that vertical asymptote right here on 0, because 0 squared is 0, and I still can't do that. We're also still going to have that same horizontal asymptote that's going to run across the x-axis, okay? So we still have both of those. Now, again, kind of some shorthanding stuff on this. Domain is going to be X can't be 0. Again, you could see that interval notation if that's what they wanted to do. Range is going to be that Y can't be, sorry, I misspoke. Range is going to be from 0 to infinity, okay? Because we never get down here, okay? If I say y can't be 0, that means I actually have negative answers. And I don't have any of those. We stay entirely up in the top end of this graph. Okay. This one, we do have this side is increasing, but the other side is decreasing. So we have an increasing side from negative infinity to 0. We have a decreasing side from 0 to infinity. Okay. We still have a discontinuous at x equals 0. Okay. And we still have a vertical asymptote and a horizontal asymptote. Okay. Vertical asymptote is going to be at x equals 0. Horizontal asymptote is going to be at y equals 0. Okay. Now, the other thing about this one, this is an even function. Okay. And it is y-axis symmetric. Okay. Which means if you can fold it in half across the y-axis and it will match up. Okay. So taking a look at a graph for one of these. Shift back up here. Sorry. Okay. Okay. So now let's talk about what this wants. The negative is going to flip over the x-axis. So left 3 and up 1. Okay, so let's get our grid space going down here. And again, we're going to start with those asymptotes. Okay, so horizontal asymptote is here. We're going to go 1, 2, 3 to the left and up 1. So we are going to see that up 1 movement with it. Okay, vertical asymptote, we're going to need to go 1, 2, 3 to the left and up 1. Okay. Okay. Now, on the original graph of this, the graph was up here and over here. It is flipped. So this is going to be here and here. Okay. So let's talk about some attributes of this. Our domain is x can't be -3. Again, I would do that x plus 3 part can't be 0. Range, y can't be 1 based on where our asymptote is. Sorry, I keep doing that. This is going to be -infinity to 1. I'm sorry, guys. I get it in my head though with the original one that we did. Okay. Now, increasing, we do have that this side is now increasing. Now, before this was decreasing, but guys, it has flipped over. So this is getting higher. So we are increasing from -3 to infinity. We are decreasing from -infinity to -3. Okay. Now then, we need to talk about, because so far we just worked off of our 2 basic graphs, and now we need to talk about how do I find like my vertical and my horizontal asymptotes, okay, if all I'm handed is an equation and maybe it's not in one of those 2 basic formats, the one over the x or the one over the x squared. Okay, so vertical asymptotes, okay, these occur when the denominator has problems. Okay, so any value of x, okay, that is going to cause us to go to 0, okay, then that is going to create a vertical asymptote. Now, horizontal asymptotes, okay, now with these, we need to look at the degree of the numerator. Okay, guys, degree is the highest power. We also need to look at the degree of the denominator. Okay, now one of three things is going to happen. And you may recall this from Algebra 2 or pre-cal. Bob, yo, bot, no, rat coat. Okay. So remember that it is bigger on bottom. It is y equals 0. If we are, bigger on top, there's none. Okay. And then if we match, if the degrees match, okay, then it is the ratio of the coefficients. Okay. Now, there is one other type of asymptote that can occur. Okay. It is a special one. It occurs when we're in a bot-no situation. Okay. If we are in a bot-no, okay, so first off, we are in bot-no, okay, but the degree of the numerator is 1 higher than the degree of the denominator, we have what's called a slant asymptote. Okay, they may also call this an oblique asymptote. Okay, and you're going to have to use polynomial division to find it. Okay, so you're going to have to use polynomial division. Now, that could be synthetic division. That could be long division. Okay, so we're going to take a look, okay, at some of these and talk about finding the situation when this all happens through. Okay, so here we go. Okay. Okay. Now, first off, we're going to do vertical asymptotes. Now, with the domain, we would do 2x minus 1 cannot equal 0. With the vertical asymptotes, we actually want to let them equal 0 because we want them to be the equation of a line. Okay. So, solving this one. There's one of them. This one, we do have a second one. I'm going to let it sit all the way down to here. Okay. Now then, horizontal asymptotes, I'm going to do the degree of the top and the degree of the bottom. The biggest power up here is a 1. Now, when we talk about degree on the bottom, you have to multiply this out, guys. This is going to give you a 2x squared, okay? The squared part of that says that my degree is 2. We have a bigger power on the bottom, so we are Bob, yo. So we have y equals 0 is a horizontal asymptote. Again, if there's a horizontal, there's not going to be a slant. Slants only come up when we're in a bot-no situation, and the degree on the top is exactly 1 higher. Okay, so taking a look at another one of these. Vertical. I only have one to deal with here, so it's going to be at x equals 3. Horizontal, I've got, oops, sorry. The degree on the top is 1 because that's that highest power. The degree on the bottom is also 1 So we are in a Ratco situation. Now, when we deal with Ratco, we're going to deal with these front coefficients in front of those x values. So this is going to be at y equals 2 over 1, which is going to be y equals 2. So there is my horizontal asymptote for that one. Okay. So, looking at another one. So, vertical. Okay. Moving into horizontal. I've got the degree on the top is 2, because that's my highest power. The degree on the bottom is 1. Now, we are bigger on the top, so we're in bot. No, but we are 1 power higher, so we are going to have a slant. Okay, so let's talk about how to get that slant. Now, you've got to do polynomial division. Now, this one you can do with synthetic because you're dividing by an x minus 2. So going back to our idea of synthetic, we have an x minus 2. That means we're going to put a plus 2 in the box. We need our coefficients in front of here. So x squared, x, we have to have that 0 in there, and our number, skip line, draw line, drop 1 down. 2 times 1 is 2. Add, I get 2. 2 times 2 is 4. That's going to give me 5. Now remember, that was x squared, so this is x, number, and remainder. The only part of this that I need is the x and the number part. This is the part that I need. So it's going to be y equals x plus 2. Okay, so this would be my slant asymptote when this comes up. Okay, now, when we go to graph, okay, rational functions, my order differs from the book, okay? First thing I look for is asymptotes. And I want all of them, okay? I want verticals, horizontal slants, whatever there is, I want to know what's off limits first, okay? Next thing is I want x-intercepts. Now, in order to get that, you're going to take the top and you're going to set it equal to 0. Now, I'm also going to want the y-intercept. Okay? And for that one, you're going to plug in 0 for that. Okay? Now, thirdly is you need points in each section or zone in the graph. Okay, so when we think about a graph picture, if we've got, you know, a couple of different asymptotes running around down here, I've got a zone over here, a zone in the middle, and a zone over here on this other edge. Okay, so we want to kind of figure out at least a couple of points in each one so that we can figure out what's going on with that graph picture. Okay, so let's take a look at graphing one of these lovely little darlings. Okay, so I'm going to kind of, so we're going to do, okay, so here we go. Verticals, I've got x minus 3 equals 0. I'm going to have x equals 3. Now, I'm going to get a little graph going down here. Okay, so I've got something over here at 3. Okay, and I'll move down a little bit here in just a second so that you can see all this other stuff that I'm doing. Horizontal, we've got degree on the top is 1, again, because that highest power is a 1. The degree on the bottom is also 1. So we are in Ratco. So again, we're going to go grab those coefficients right up in front of the x's. So we are at y equals 2 over 1, which is going to be at 2. So I'm going to go mark that. Okay. So now I need to get my x-intercepts. So we're going to take the top and we're going to set it equal to 0. Just a little bit so you can see what I'm doing. Okay, so I've got x equals -1/2. So I'm going to go mark that. So here's my dot right there. Okay, I want to get my y-intercept, and that's I'm going to plug in 0. So I've got 2 times 0 plus 1 over 0 minus 3. That is going to give me 1 over -3. So it's -1/3. So that's going to be here. Now, guys, based on those 2 dots in the asymptotes, I know that this thing is probably supposed to arch right through here. But I don't know where this other piece of my graph is supposed to sit. Is it up here? Is it down here? I don't know. So I'm going to make myself a little table. Okay, go back up over here a little bit. Okay. And I need to pick something on this side. Excuse me, I need to pick something over here on this side of the line. So I'm going to pick 4. Okay. So 2 times 4 is 8 plus 1 is 9 over 4 minus 3 is 1. So I'm going to be up here at like 9. That dot's going to be like way up here. Okay. Now with that dot being there, that says this piece must come in an arch kind of right like that. Okay. So now let's take a look at another one. Okay. So we're going to look at x plus 1 over 2x squared plus 5x minus 3. Okay. Now, guys, first thing that we're going to do is we're going to factor the bottom of this. So it's going to be a 2x and an x. Let's see, we need a 3 and a 1. More positive, less negative. Okay. So now, vertical asymptotes are going to be at 2x minus 1 equals 0. And I've got one at x plus 3 equals 0. So it's going to be at x equals -3. So again, I'm going to get a grid space going down here. So I've got one at 1/2. So that's kind of like there. And then I've got one over here at 3. Okay. So now, horizontal asymptote. Degree on the top is a 1, again, because it's based on the biggest power. The degree on the bottom is the squared, so that's a 2. So we are in Bob Yo. I'm going to have a horizontal asymptote right along 0. Okay, so it's going to be along the x-axis. Now then, x-intercepts. We're going to take that top and set it equal to 0. So I touch the x-axis at -1. Now, you may be looking at that going, how is that possible when she's already put a horizontal asymptote on that? It is because horizontal asymptotes deal with the outside edges of the graph. Sometimes in the middle, you may get like a 1 spot touched off where it touches on the x-axis once, and it's okay, okay? Don't like have a conniption over it. It will be fine, okay? Now, y-intercept, we're going to plug in 0. So I'm going to have 0 plus 1 is 1 on the top. That's going to be 0. That's going to be 0. So I'm going to have -3 on the bottom. So I'm at -1/3. So it's going to be about there. Now, I do not know what is happening with the rest of this because, guys, this could be like a parabola looking shape in the middle, or it may be an S-curvy thing in the middle. All I've got is like these 2 pieces go this way. That's all I know right now. And I definitely don't know what's going on in here or here. So I need to do a lot of spot checking, okay? So I'm going to make me a little table over here. So this is at -3. So we're going to plug in -4. So -4 plus 1 is going to be -3 over, let's see, that's going to be 16, 32 minus 20. 32 minus 32 minus 20. No. Okay. I'm just going to stick this on a calculator. Okay, 9, so that's going to be -1/3. So over here, I've got another dot right about here. That tells me that this is going to be here. Okay. Now, I'm going to go ahead and try this -2 spot. Okay, so that I can figure out what's going on with this other one. So -2 plus 1 is going to be -1 over -5. So that's going to be 1/5. So that's going to be here. That tells me this is going to be an S curve. Okay. Now, I'm going to pick up over here on the other side, and I'm going to pick the number 1. So I'm going to have 1 plus 1 is 2 over 1 squared is going to be 1, so it's going to be 2. Plus 5 is 7. Minus 3 is 4. So it's going to be 1/2. So it's going to be here. So that tells me this piece is going to be over here. Okay. So again, I'm using different portions of the graph to help me out in different information that we can do when stuff happens. Okay. So now let's take a look at one that has a slant asymptote in it. Okay. So that you understand how to work with those. Okay. So we've got, and this is the same one that we were just working with just a bit ago. Okay, so again, kind of processing through our graphing method. We're going to take that denominator and set it equal to 0. So I'm going to, again, go ahead and get my grid space going down here. So I've got a vertical asymptote at 2. Our degree on the top is 2. Our degree on the bottom is 1. So we are no, but we are 1 higher on the top. So we have a slant. So again, I'm going to do our synthetic division. X minus 2 means I'm putting a plus 2 in the box. I've got a 1, 0, 1. And again, the part about this that I need. So I have y equals x plus 2. So we're going to go graph that the way that we normally would. Okay. So it starts at 2. So I'm going to put a dot at 2. And then it is up 1 over 1, up 1 over 1. Guys, you can come down 1, back 1, down 1, back 1. Okay. It is still an asymptote, so it does need to be dashed when it's brought in. Okay. So we've got a graph that kind of looks like this. So processing further along. X-intercepts, we've got x squared plus 1 equal to 0. Okay, guys, square root of -1 is I. That means there are none. I don't ever hit the x-axis at all in any of this, okay? For my y-intercept, okay, if I plug in 0, I'm going to have 0 plus 1 is 1. 0 minus 2 is -2. So I'm at -1/2. So that's going to be here. Now keep in mind that it said I cannot touch the x-axis. So that means this thing's going to come over and stay on this and here. Okay. And I knew that because I can't touch the x-axis because it said I had none. Now, still need to know what's going on kind of over here on this other side. So that line is at 2. So I'm going to try 3. 3 squared is 9 plus 1 is 10. 3 minus 2 is 1. So that dot is going to be way up here. So the other part of this graph is probably doing like that. Okay. Okay. So there's one with a slant. Now, we have just a couple more things to talk about in this section. Okay. One of the things is what's called a removable discontinuity. Okay. Sometimes it may be called a point of discontinuity. It may also be called, what most of us call it is a hole. Okay. Now, Holes happen when you can factor, okay, the top and the bottom. The top of this is a difference of squares or a dots pattern, okay? A hole happens when you can cross off a term top to bottom. So the hole is going to happen when this x minus 2 would have been set equal to 0. So the hole is going to happen when x is 2. Now, the way that you find this, okay, is you are going to graph what you've got left. So in this case, I've got x plus 2. So I'm going to graph that equation. So we start at 2. And then when I get to 2, wherever that is in my pattern, I'm going to put a hole. So I'm going to go from here. I'm going to go up 1 over 1. That's still a solid dot. And then I'm going to go up 1 over 1. Now, instead of putting a solid dot here, I'm going to put a hole right there. And again, with it being a line, I can go in and put another couple dots. Okay. But we are going to be a solid line this way. And then it extends out the other side. Okay. Now, the last thing that we've got to discuss, okay, in this is kind of the application stuff. So they give us an equation that says x squared over 2, 1 minus x. This gives us what's called the average number of vehicles waiting in line to enter a ramp at like a parking garage, okay? Where X represents our traffic intensity. So the difference here would be rush hour traffic or early morning traffic, kind of getting to work traffic, versus something like 2 o'clock in the afternoon or 9:30 in the morning, okay, when there's not going to be as much traffic out on the work. So they ask us to compute or find, and again, this was f of x, okay? They ask us to find 0.8125, okay? So we're going to have 0.8125 squared over 2 times 1 minus, 0.8125, okay? Now, I'm going to clean this up just a little bit. So we get 0.66015625, and that is the full top. And I get 0.375 on the bottom. So then doing that division, we get that this is 1.76 roughly, okay? So we're saying that there are roughly 1.76 cars waiting to get into this parking garage or this parking ramp when the traffic intensity level is this, okay? Now it asks what happens to the number of vehicles as the traffic intensity approaches 1, okay? So what we can do for that, okay, is we can make this number kind of really, really big. We can't put 1 in because 1 minus 1 is 0. But I can put in something like 999, okay? And so I can do 9 or 2 times 1 minus 0.999. Okay, and we get 0.998001 over and we get, okay, so what happens to the number of vehicles? The number of vehicles gets really big, okay? So now at 0.999, if that was the intensity, we've got almost 500 cars waiting to get into this parking garage, okay? So as the traffic intensity approaches 1, the number of vehicles is going to increase as we go, okay? So that is the end of our section 3.5.